Welcome back, guys. All right, so just kind of progressing through. This is all a topic we call 11.1. The total topic is called permutations, and I'm breaking this down into 3 videos. This is kind of this is definitely a longer first topic. We'll definitely be spending at least 2 days in class on this topic. So, example 9 says, suppose a football coach has 5 offensive linemen. How many 5-person starting lineups could he make? Okay, so we did questions like this. Now, the idea is like sorry, it doesn't matter if you don't know anything about football, it's okay, but the order of the players does middle. So the player on the left is different than the player on the right and stuff like that. So if the order does matter. Really what it comes down to is we're making 5 choices. Okay, so we have 5 different positions over here. Now, how many choices do I have here? Well, I can place one of the 5 here. Then I have 4 left. And then I have 3 left. And then 2 left. And then 1 left. Okay, so if I multiply these together, we get an answer of 120. Okay, so what we see, guys, we see these type of calculations a lot. Okay, and so what we do for this is like, well, in math, we always want to be able to simplify and condense something like this. Okay, so in order to condense this type of calculation, we can write this. Okay, now guys, I know this looks like the strangest math symbol you've ever seen. Like that, it's an exclamation mark, but in math, this actually means something, and this means 5 factorial. Okay, so anytime we see an exclamation mark like that, which is the factorial symbol, this means 5, and then you count down by 1, then 4, then 3, then 2, then 1. So you go 5, 4, 3, 2, 1. You multiply those answers together, and you get an answer of 120. Okay, so the number of ways that you can arrange n objects in a line. So in this case, like I had my n value is 5, but if I have n objects, would be n factorial, like that. All right, so evaluates. 6 times 5 times 4 times 3 times 2 times 1 equals 720. Okay, we don't need to do this every time. Okay, so guys, for a question like this, 10 factorial, there is a way that we can do this in our calculator. And what you want to do is you want to press the math button, and then you want to go over to PRB, which is for probability. And you want to go down to the option where it says the factorial. So you can go 10, math probability factorial. I'm sorry, guys, I actually do not have a calculator with me right now, so I have to do this on my phone. Huge number. Sorry, guys, I just want to double check this. Yeah, number is 3,628,800. Okay, so this number gets huge fast. Okay, now a couple trivial ones over here. 1 factorial is 1. Okay, now this is the one over here which is not so trivial, but this answer is going to be 1. Guys, this explanation is not perfect, but this is the way I explain it. How many ways can you arrange 0 objects? Okay, and the answer, so this question, the answer, 1 way. You don't arrange anything. Okay, now guys, this explanation is not perfect. I know some of you guys are going to be scratching your heads on this one over here, but this is the best explanation to kind of give for this, but it's more than this. Algebraically, we need this to equal something. Okay, guys, my first thought was that this answer should equal 0. Okay, but we need 0 factorial to equal something other than 0. Okay, because what you're going to find later on, we need to divide by 0 factorial sometimes, and like this answer can't be 0, so this answer is going to be defined as 1. Okay, and again, how many ways can you arrange 0 objects? There's one way. You don't arrange anything. That's the way that you arrange this over here. Okay? So for option E, we have 6 factorial divided by 4 factorial. Okay, so this is going to be 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial, 4 times 3 times 2 times 1. Okay, so what you're going to see here is that the 4's cancel out, the 3's cancel out, the 2's cancel out, and the 1's cancel out. And we're left with 6 times 5 equals 30. Okay, I'm going to do this question one more time. This is the technique that we're going to have to solve, and we're going to have to use this technique for a few more difficult problems, like in example F, for example. The way this works, is that 6 factorial is 6 times 5. But what I'm going to do here is I'm going to write 4 factorial and stop. And the reason, well, what's 4 factorial? 4 factorial will just be 4 times 3 times 2 times 1, okay? But if I have a 4 factorial here and I have a 4 factorial in the bottom, these two terms cancel out, and we're left with 6 times 5, which is 30. Okay. For question F, we have to do the same thing. This is a more general example, but it's n factorial over n minus 2 factorial. Now, how do you write out n factorial? Well, n factorial is equals n, and then if I'm counting down, my next number would be n minus 1. Okay. My next number after that would be n minus 2, and then n minus 3, n minus 4, n minus 5, and keep on going. But the question is, where do we stop? Well, the answer is it doesn't really matter. Because if I put a factorial symbol over here, this just means I'm going to keep counting down until I hit 1, but I have an n minus 2 factorial in the bottom, right? So the n minus 2 factorial in the bottom cancels here and cancels here, and we're left with n times n minus 1, which is n squared minus n. Okay, so this is how this type of question works, like that. All right, express as a single factorial. Okay, so I'm going to do this question the long way first. What's 9 times 8 factorial equal? Well, equals 9, and then 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, well, what's this equal? Isn't this equal to 9 factorial? Okay, I'm starting at 9, counting down over here. So 9 times 8 factorial is just the same thing as 9 factorial. The same idea here. I'm starting at n plus 1, and I'm counting down to n, counting down to n minus 1, and then n minus 2, n minus 3, n minus 4, n minus 5, and so forth like that. This equals n plus 1 factorial, like that. Okay, so we need to solve for n over here. Okay, n factorial equals 24. For a question like that, for question A, there's not a real nice way to do this. I'm just going to use guess and check. Well, what is 1 factorial equals 1? 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is 24. Therefore, n equals 4. Okay, guys, there's not a real nice way to do this question over here. Like that. There is using like n times n minus 1 times n minus 2 and stuff like that, but the problem is we don't know where we're going to stop over here for this question, right? So just there's not a nice way to do this one algebraically, but we're just have to do a guess and check for this one. For example B, there is a nice way to do this one algebraically. What we saw in the last example is how do we expand something like this? Well, n factorial over n minus 2 factorial the rule is for a question like this, is you want to expand the bigger factorial. Now, n is bigger than n minus 2. So I'm going to start expanding n factorial to n, count down by 1, n minus 1, count down by 2, n minus 2 factorial. Well, here, these two can now cancel out. Okay, and now this becomes a Math 20 question. It's n squared minus n equals 56. N squared minus n minus 56 equals 0. This means we have n minus 8, n plus 7 equals 0. That means n equals 8, or n equals negative 7. Okay. Now, in this unit over here, guys, what does n factorial represent? It means arrangement of a number of objects. Okay. Now, if I say you can arrange 8 objects, this makes sense. How many ways can you arrange negative 7 objects? This does not make sense. Okay. So in this case over here, we have to exclude the answer of n. Okay. So in other words, n will always be positive in this unit. Okay, similar idea for this question over here. We have n plus 1 factorial over 3 factorial n minus 1 factorial equals 5. Rule for these types, I'm going to say, is expand the bigger factorial. So what's bigger, n plus 1 or n minus 1? Well, n plus 1 is going to be bigger. So when I say expand that, what I mean is n plus 1 factorial is n plus 1 times n minus 1 factorial. What's 3 factorial equal? 3 factorial is 3 times 2 times 1, which is 6. So that's going to be 6 times n minus 1 factorial. And these two cancel out like this. Okay. Now, again, this is another Math 20 type question over here. What would I do next? I would multiply both sides of the equation times 6 to get cancellation here. So the right-hand side equals 30. And this is n squared plus n. Like we did in the last example, guys, we're going to exclude any negative solutions that we have over here because n can't be a negative number. So solutions can be n equals 5 for this guy. All right, guys, so there's kind of an intro to factorial notation. There's plenty of practice for you to do on this stuff, guys, and you need to kind of just do lots of this stuff so you guys get good at these types of questions over here. All right, see you in the next video.